Let's talk about a revolution that's happening right in front of our eyes. And I mean that literally. It's all about how security cameras are evolving. They're not just recording anymore. They're actually starting to understand what they're seeing. This is all about how we're teaching a camera to, well, see.
But before we get into the tech, let's start with a feeling I'm sure you know. It's that little buzz on your phone, a security alert. You open up the app, maybe your heart's beating just a little bit faster, only to see, what? A tree branch swaying in the wind? Or maybe a spider building a web right in front of the lens? So why are so many security systems so jumpy? Why do they cry wolf all the time?
Well, the scale of this problem is kind of staggering. According to security experts, some of these older systems can have a false alarm rate of up to 95%. Think about that, 95. At that point, it's not a security tool, it's just a really annoying weather app. And this incredible inefficiency, it's the exact problem that new AI is being built to solve.
So how in the world did we end up with a 95% failure rate? Well, it turns out the problem wasn't the camera's lens, it was the camera's brain, or lack thereof. It really all boils down to this fundamental shift, right? A shift from just seeing motion to actually understanding meaning.
And you can see the difference right here. The old way, what we call pixel motion, was basically a digital game of spot the difference. The camera would look at one frame, then the next, and if enough of those tiny dots of color, the pixels, changed, it would just yell alarm. A shadow moves, pixels change, you get an alarm. It's simple, but it's dumb. The new way, computer vision, is playing a totally different sport. It's not looking at individual pixels anymore. It's looking for shapes, for patterns. It's actually trying to understand what's in the picture. And here it is. This is the payoff. This one sentence really captures the entire leap in intelligence. The new camera doesn't just see a big moving blob of changing colors. No, it sees the shape. It sees the way it moves and it concludes, you know what? That's a tree. And the result? Nothing. Silence. No false alarm. That's the difference between simple reaction and genuine recognition. Okay, so that's the what, but how does a camera actually do all that? It can feel a little bit like magic, right? But it's not. It's actually a pretty logical three-layer system. We call this the AI stack, and it's how a simple camera learns to see the world. So let's break it down. The easiest way to think about the AI stack is to think of it like a person. So step one, you've got the model. That's the brain. It's the software that's done all the learning. Step two is the hardware. That's the muscle. It's the physical chip that actually runs the software. And finally, step three is the application. That's the purpose, the real-world value. It's the action you take based on what you've seen and thought about. So you've got the brain, the muscle, and the value. Let's look at each one. So the brain's work is actually split into two very different jobs. The first one is called training. Now this is like the schoolhouse phase, and it happens way before that camera ever gets to you back at the factory. A massive supercomputer gets fed millions and millions of photos of, say, a person, until it learns the fundamental pattern of what human looks like. The second job is called inference. This is what happens live, right on your camera. That trained brain is now out in the world, looking at video and making an educated guess or an inference, like, I'm 98% sure that shape is a human. So all the heavy lifting happens during training, the camera just has to apply what it learned. All right, now for the muscle. And just like our bodies have different muscles for different jobs, AI has two main types of hardware. On one side, you have the heavyweight champion, the GPU. You can think of these as the absolute powerhouses you'd find in a big server, doing really demanding stuff like facial recognition. But on the other side, you've got the lean, super efficient NPU. This is a tiny little chip that lives right inside the camera itself, and it's perfect for those quick, basic tasks like telling a person apart from a car.
So, why do all this? This is the final layer, the value. This is where the rubber meets the road, where just seeing something turns into doing something. For security, the value is all about precision. Instead of a useless motion-detected alert, you get a really specific rule. Alert a guard if a human is detected in Zone A after midnight. For a business, the value is intelligence. You can ask your camera system, hey, count how many humans entered the store between 12 and 1. This isn't just raw data anymore, it's actual, actionable insight.
Okay, so we've got the brain, the muscle, and the value. But there's a huge, practical question we have to answer. Where does all of this processing actually happen? Does it happen inside the camera, in a server in a back closet, or somewhere out there in the cloud? Believe it or not, this decision is often the most critical and most expensive one you're going to make.
This table really lays out the three main options. First up, you have Edge AI. This is where all the analytics run right on a chip that's inside the camera. It's super fast, it's cheap, and it barely uses any of your internet bandwidth.
The catch? The brain power is pretty limited. Next, you've got server AI. This is where all your video streams to a powerful computer you have on site. It's way smarter. It can handle really complex things like license plate recognition. The big downside? Those servers are pricey, often starting at $5,000 or more. And finally, there's cloud AI. This is where your video gets sent off to the giant data centers of a company like Google or Amazon. The intelligence here is practically infinite, but that comes with high monthly fees, and you better have a really good internet connection.
Now, to really get a handle on all this, we kind of need to learn how to speak the language of the AI. It has a specific vocabulary it uses to describe what it sees, and knowing these terms is key to understanding what these systems can actually do. So let's learn the dialect of a smart camera.
The best way to think about it is in levels of detail. So the most basic level is called classification. This is just identifying what an object is. Is it a human, a vehicle, an animal? Simple. The next level up is attribute extraction. Now we're getting into the details. It's not just a human. It's a human wearing a red shirt and a hat. It's not just a vehicle. It's a white truck. Then you have the highest level, behavioral analytics. This isn't about what an object is. It's about what it's doing. Is that person loitering? Did someone just fall down? Is a fight breaking out? This is where AI starts to get really smart and interpret intent.
Of course, no system is perfect, and it's absolutely critical to understand how they can fail. There are really two types of errors. The first is a false positive. This is when the alarm goes off, but nothing's actually there, like a scarecrow getting flagged as a human. Okay, that's annoying. But the other type of error, a false negative, that is far more serious. That's when a real thief walks right past the camera and it completely fails to send an alert. That's not just annoying, that's dangerous. And here's the crucial takeaway. You can deal with a few false alarms, but a single false negative can defeat the entire purpose of having the system in the first place.
So here we are. We've gone from cameras that just saw meaningless pixels to cameras that can identify patterns, people, what they're wearing, and even what they're doing. The technology is here, and you know it's only getting more and more powerful every single day. So as these cameras learn to see more and more of our world, the real question we have to ask ourselves is, what should we be asking them to look for?